In the endless silence of space, fragments of creation drift unseen. Most pass harmlessly, but some come close enough to remind us of our fragility. In September 2025, a rock no larger than a bus, later named 2025 KV5, swept past Earth at twice the distance of the Moon. It posed no threat. Yet, its late discovery, only 9 days before arrival, exposed how thin our watchful net still is. One small shift, and a harmless visitor could have become disaster. For a fleeting moment, humanity glimpsed the truth. We live beneath a sky filled with wanderers, most unseen, each one a question mark cast across our future. Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video. The discovery of asteroid 2025 KV5 began like so many others. Not with a flash in the sky or a sudden alarm, but with faint points of light shifting against the backdrop of stars. On August 24, 2025, survey telescopes noticed an object that did not belong among the fixed constellations. It was small, dim, and fast. At first glance, it could have been overlooked. A mere speck lost in a sky full of motion. Yet careful tracking soon revealed it was something far more significant, a near-Earth object making its way toward our planet. The asteroid measured only about 11 meters across, comparable to the length of a common city bus. On human scales it was tiny, yet in cosmic terms it was large enough to hold real consequence. Traveling at nearly 22,000 kilometers per hour. Its path brought it to within 800,000 kilometers of Earth, about twice the distance of the Moon. In the quiet of that approach, it became part of a story humanity has long lived within, but rarely perceives: the ongoing passage of cosmic debris through Earth's neighborhood. What struck scientists most was the timing. KV5 was detected just 9 days before closest approach. That is a short margin, a reminder that while technology has advanced, the sky remains vast and full of hidden travelers. Networks like Pan-STARRS in Hawaii and Atlas in both hemispheres constantly scan the heavens. Their wide-field cameras capture countless stars each night, and software combs through images to find the telltale shift of an asteroid. It is painstaking, relentless work, yet even so many objects still slip by unseen. When astronomers calculated the orbit of KV5, they discovered it takes almost the same amount of time to circle the Sun as Earth does, roughly 359 days. This near resonance means it crosses our planet's path regularly, though not always closely. The 2025 pass was harmless, yet its orbit ensures it will return again in 2125, a full century later. Future generations will be the ones to observe that encounter. The discovery of KV5 was not a solitary effort. It drew on decades of development in planetary defense. The gradual building of a worldwide system designed to track and study near-Earth objects. In the 20th century, such a rock might never have been found until it streaked into the atmosphere. Astronomers of that era relied on photographic plates and manual comparisons, an exhausting process. Today, artificial intelligence flags candidates within hours, and radar beams refine trajectories with extraordinary precision. Yet even with all this progress, KV5 proved that gaps remain. Its late detection highlighted the limitations of ground-based surveys, particularly against objects approaching from directions near the Sun. It also underscored how easily a small asteroid could pass through the system unnoticed. The discovery carried emotional weight, as well as scientific interest. For a fleeting moment, the world was reminded that Earth is not isolated. It spins within a region populated by wanderers left from the solar system's birth. Most pass quietly, but each one is a messenger. Some whisper of the past, carrying chemistry that dates back 4.5 billion years. Others remind of risk, that even a small object can unleash tremendous energy if it collides with the atmosphere. KV5, safely passing at 500,000 miles, embodied both sides of this truth. And so the discovery phase concluded not with alarm, but with awareness. A bus-sized asteroid had brushed past Earth. It left no crater, no shockwave, only data and reflection. Yet in that moment, it became a story, one more thread woven into the long narrative of humanity's relationship with the cosmos. The safe passage of 2025 KV5 might have ended the story, but the manner of its discovery produced a second chapter, one filled with unease. For the true shock was not that an asteroid had passed close to Earth, but that it was found so late, detected only days before its arrival. This raised the uncomfortable realization that humanity's watchfulness is still incomplete. A rock large enough to devastate a city was invisible until the final week of its journey. Had its path been slightly different, it could have been an incoming disaster with almost no warning. The thought alone unsettled scientists and the public alike. Detection systems today are powerful. Telescopes scan every night, software sorts data at enormous speed, and radar confirms orbits with precision. But blind spots remain. Ground-based telescopes cannot see into the glare of the sun. Many asteroids approach from that hidden direction. Others are simply too small and dark to be noticed until they are close. KV-5 belonged to that difficult category, faint until nearly upon us. The implications are sobering. An object 11 meters across cannot end civilization, but it can cause chaos. In 2013, a 20-meter asteroid exploded above Chelyabinsk in Russia, releasing energy equivalent to 30 atomic bombs. More than 1,000 people were injured by shattered glass and falling debris. That meteor came without warning. KV-5 could have done the same. The only difference was chance. It missed not because of preparation, but because the orbit happened to align at a safe distance. History offers even darker reminders. In 1908, a 50-meter body detonated over Siberia, flattening thousands of square kilometers of forest. Had that event occurred above a city, the consequences would have been catastrophic. These precedents show that even small asteroids are dangerous, and they arrive more often than we might wish to believe. The shock of KV-5 therefore lies in scale and probability. There are millions of near-Earth objects under 140 meters in size. They are too small to trigger global extinction, but large enough to devastate regions. Statistically, Earth will be struck again. It is not a question of if, but when. Each discovery narrows uncertainty, but also confirms the magnitude of the unseen. Scientists know the difficulty of prediction. Orbital paths follow Newton's laws and Einstein's refinements, yet small forces complicate the picture. Sunlight heating one side of a rotating asteroid produces a tiny thrust. The Yarkovsky effect, which slowly shifts orbits over decades. Gravitational nudges from planets add further uncertainty. A trajectory calculated today may be altered over centuries in ways hard to predict. KV-5's orbit is safe for now, but vigilance must be continuous. The realization of how easily such objects evade detection becomes a philosophical weight. Humanity has built cities, cultures, technologies, yet all of it rests under a sky where unseen stones wander freely. The Chelyabinsk event showed the atmosphere does not guarantee protection. The Tunguska event showed how random location determines outcome. And KV-5 showed how late humanity might still be in noticing. For astronomers, this shock is not paralysis, but motivation. It emphasizes the need for future instruments, such as space-based infrared observatories, that can see where ground telescopes cannot. It strengthens the case for continuous improvement, for cooperation across nations, for rehearsals of response plans. The shock, though unsettling, becomes fuel for progress. But beyond science, it also reshapes perspective. Each near miss is a reminder that certainty is fleeting, and that our place in the cosmos is not insulated but exposed. For KV-5, the moment passed quietly. For the next, the outcome may not be so gentle. The scientific shock, then, is not simply that an asteroid nearly went unnoticed. It is the confrontation with truth. Earth moves through a shooting gallery of debris. Humanity can measure, can predict, can prepare, but it cannot change the fact of exposure. What was overlooked this time was caught in time. What is overlooked next time may not be. In that knowledge lies both unease and the determination to see further, to know more, and to prepare for what the cosmos will inevitably send our way. In the days following the discovery of 2025 KV-5, astronomers turned from shock to calculation. A newly found near-Earth object is never merely a dot across the telescope. It is the beginning of a puzzle, the challenge of fitting fragments of light into the language of mathematics. To decipher a path carved in the solar system long before humanity ever existed. From those faint traces, orbital mechanics unfolds, a story told through equations that reach back to Newton and extend through Einstein, weaving together the past and the future of a celestial wanderer. The first calculations revealed that the asteroid's orbit mirrored Earth's in duration, completing a journey around the Sun in nearly the same time, 359.4 days. This resonance creates a subtle rhythm. Every year it returns to roughly the same region, but never in quite the same place, tugged by the gravity of Earth, Venus, and even Jupiter in distant whispers. To the human eye, it seems almost coincidental, but in celestial terms, it is a choreography set into motion billions of years ago. The asteroid's close approach in 2025 was not a new event, but a recurrence in a cycle that repeats across centuries. To understand why the asteroid will not return for 100 years, one must look deeper into how orbital predictions are made. When an object is first discovered, its path is only partially known. Observations refine parameters, such as semi-major axis, eccentricity, inclination, and longitude of ascending node. These values describe the ellipse it follows, but with uncertainties that gradually shrink as new data is added. Radar, such as that from the Goldstone Deep Space Communications Complex, sharpens those uncertainties dramatically, pinning down position and velocity to a precision of meters and seconds. Each refinement pushes the orbital solution forward, allowing astronomers to project decades, even centuries into the future. Yet prediction is not permanence. The gravitational pull of planets, small though it may be, over one pass, accumulates across time. An encounter with Earth may alter an asteroid's path by kilometers, but after years those kilometers compound into thousands. The asteroid, 2025 KV-5, passed Earth at 500,000 miles, a safe distance. But the very geometry of that pass changed its velocity fractionally, enough that by the time it returns in 2125, its trajectory will differ by hundreds of thousands of miles, ensuring a more distant flyby at approximately 830,000 miles. A safe outcome, but a demonstration of how small nudges echo across centuries. This method of calculation has precedent. When Apophis was first discovered in 2004, early models suggested a small, but real chance of collision in 2029. Subsequent refinements eliminated that possibility, revealing that its path, though startlingly close, would not intersect Earth. The evolution of Apophis's predictions became a lesson in humility. Initial uncertainties magnify fears, but with time and data, clarity emerges. In the case of QV5, the rapid application of radar and optical tracking meant that its century-long return could be predicted with high confidence within days of discovery. Yet, lurking beneath those calculations, subtle forces persist. One of them is the Yarkovsky effect, a tiny thrust created when sunlight heats one side of a rotating asteroid and re-radiates thermal energy. Over decades, this can shift orbits by tens of kilometers, altering predictions in ways invisible in the short term. For KV-5, its small size makes it particularly susceptible to such thermal forces. Astronomers know this, and thus predictions, though reliable, are never final. Every century-scale forecast is provisional, subject to the slow sculpting hand of sunlight and gravity. The investigation also reaches back into history. Asteroids like QV5 are fragments, relics of collisions in the main belt, or even ejecta from larger bodies, shattered in ancient times. Their paths are chaotic, altered by planetary encounters long before they neared Earth. To trace their journeys is to follow echoes of deep time. Orbital integrations can extend backwards, revealing possible origins. But after a few million years, uncertainty reigns, trajectories blurred by countless gravitational interactions. What is certain is that QV5 has wandered the inner solar system for thousands of years, unseen, until now. As astronomers modeled the asteroid's past, they found that it had crossed Earth's orbital neighborhood before. Perhaps it came nearer than it did in 2025, perhaps farther. Each approach shifts its story slightly, building toward the century-long cycle that now carries it away. That rhythm, invisible to daily life, is the tempo of celestial dynamics, steady, indifferent, and inexorable. The tools of modern science allow these deep investigations. Supercomputers run numerical integrations, calculating gravitational interactions for hundreds of years into the future. They model not only the Sun and planets, but hundreds of thousands of known asteroids, weaving together a simulation of the solar system that mirrors reality with astonishing fidelity. Into this virtual cosmos, the faint points of observation for QV5 are fed, and the program projects its path forward and back, generating probability distributions for its location at any moment. These models are the closest humanity comes to foresight, a glimpse into futures already determined by physics. But foresight is never absolute. A missed observation, an underestimated perturbation, or a hidden resonance can alter outcomes. In orbital dynamics, chaos is not dramatic, but gradual, the slow divergence of trajectories that begins with imperceptible differences. This is why astronomers continue to track objects long after safe flybys. Each encounter adds a new data point, refining predictions for the centuries ahead. For QV5, although its next return is distant in time, future generations will recalibrate its path, ensuring that the story remains continuous. The emotional weight of these calculations cannot be ignored. For the public, the discovery of a bus-sized asteroid 9 days before its approach seems alarming. For scientists, it is both routine and revealing. Routine, because such objects pass often, discovered with little notice, yet almost always harmless. Revealing, because each detection adds to the mosaic of knowledge, filling in the blind spots that still exist. The deeper investigation of QV5 is not just about this single rock, but about the methods, the instruments, and the philosophy of vigilance. It is about refining the art of predicting not just where a stone will be tomorrow, but where it will drift 100 years hence. In this way, the investigation transcends the asteroid itself. It becomes a meditation on precision and fragility, on the thinness of the veil that separates certainty from uncertainty. Each orbital element, each correction, each gravitational tug is part of a larger narrative, the unfolding of a cosmic clockwork that humanity can now read, if imperfectly. The discovery of QV5 opened that book for a moment, and the deeper investigation allowed us to trace a few more lines to glimpse how the clock ticks forward, how stones wander, and how Earth, fragile and small, remains a participant in this endless celestial dance. The discovery of 2025 QV5 might have ended in reassurance. Its path was safe, its return distant, its size incapable of global destruction. Yet reassurance quickly fades when set against the broader canvas. For every known asteroid, there are countless more uncharted. The late detection of QV5 was not an exception, but a symptom of a deeper reality. Humanity is surrounded by a population of small wanderers, many of them invisible until they cross into our orbit, and some perhaps destined for collision. The unsettling truth is that warning times remain painfully short. For a rock 10 to 20 meters across, like QV5, even the best systems rarely provide more than a week's notice. In some cases, days. In others, as Chelyabinsk proved, no warning at all. On that February morning in 2013, a meteor exploded in the skies of Russia, and the world was reminded that the atmosphere itself is no impenetrable shield. More than 1,000 people were injured by shattered glass, buildings shook, and an object smaller than a bus demonstrated how fragile human security can be when measured against the heavens. If QV5 had been on a different path, the same could have happened again. Perhaps over a city less prepared, with consequences more dire. The mystery deepens when considering the unknown populations. Observational bias hides asteroids that approach from the direction of the sun. Their trajectories lie cloaked in daylight glare, unreachable by ground-based telescopes. These so-called daylight objects may constitute some of the most dangerous threats, for they arrive unseen until the final hours. Other populations remain hidden in Earth's gravitational shadows. Trojan asteroids, co-orbiting ahead and behind Earth in its orbit, linger in regions difficult to monitor. They are not numerous compared to the main belt, but their presence reminds astronomers that even near our own orbital path, secrets remain. Statistics from recent surveys offer sobering perspective. Objects the size of QV5 are expected to strike Earth every few centuries. Larger ones, capable of leveling entire regions, appear on scales of thousands of years. Civilization may endure generations without incident, yet the cosmos does not follow human calendars. The probability is inevitable, even if timing is uncertain. Each new detection, each near miss, adds weight to this realization. Humanity lives within a cosmic shooting gallery, its orbit intersecting paths of debris left from planetary formation. Escalation is not merely numerical. It is psychological. Each late discovery becomes a reminder that our instruments are not omniscient, that gaps remain in the global survey. The scientific community knows this, and it drives the push for next-generation tools. The forthcoming Flyer telescope in Sicily will divide the sky into multiple channels, scanning with unprecedented breadth. The NEO-Surveyor, a space-based infrared observatory, will peer into the regions near the Sun, where optical telescopes cannot look. Together, they promise to uncover thousands of hidden wanderers. Yet until they are operational, the blind spots persist. The passage of QV5 raises another question. If such objects are only now being found days before arrival, how many others have slipped by, unnoticed? Not every asteroid that approaches Earth is catalogued. Some pass quietly at safe distances, never detected, their existence unknown. Others are seen once, then lost against the starfields, their orbits too poorly constrained to follow. These lost asteroids are specters, known only as brief flashes of data, their fates uncertain. In this uncertainty lies unease. The cosmos is not empty, but filled with silent travelers, some of which may yet return. What deepens the mystery further is the unpredictability of resonance. Small bodies can fall into orbital relationships with planets that amplify their paths. A subtle shift may cause them to repeat encounters, gradually drawing nearer. The dynamics are complex, sensitive to initial conditions, and beyond simple intuition. A rock the size of QV5 may appear harmless in one century, only to find a new trajectory in the next, altered by gravity's invisible hand. For astronomers, this unpredictability is both fascination and dread. Beyond science lies the philosophical weight. Humanity's sense of permanence, its cities, its history, exists on a planet perpetually exposed. The Earth's atmosphere is vast, but it is not invulnerable. Each meteor streak across the night sky is a reminder of debris colliding with air. Most burn unnoticed, grains of dust igniting briefly, but among them are larger stones, each a potential disruption. The cosmos does not aim them. It does not choose targets. It simply moves according to laws older than life itself, and Earth happens to lie in the path. In this context, the near miss of 2025 QV5 is more than an isolated story. It is a symbol of how much remains unknown. For astronomers, the discovery deepens the sense of urgency. For the public, it deepens the sense of fragility. The asteroid was not dangerous, but its lateness reminds us that others could be. The escalation lies not in what happened, but in what might yet happen. The mystery lies not in the known trajectory, but in the unknown multitude. As QV5 recedes into the outer darkness, its memory lingers, not because it threatened, but because it revealed. It showed that our watch is partial, our preparedness incomplete, and our place in the solar system exposed. The scientific investigation becomes an existential meditation. For in the silence of the cosmos, in the endless trajectories of stone and ice, humanity is reminded that certainty is never absolute, and vigilance is never complete. The mystery does not fade. It deepens with every rock discovered, every rock overlooked, every rock that still drifts unseen through the night. The near miss of 2025 QV5 has been explained, its orbit traced, its distance assured. Yet within the safe margins lies the fertile ground of speculation. An asteroid, even one scarcely larger than a bus, is not only a passing stone. It is a remnant of the early solar system, a survivor of planetary birth. Each close encounter invites not only calculations, but questions. What stories might this wanderer carry within its rock and dust, and what might have been had its path shifted by even the smallest degree? One line of speculation begins at its origin. Asteroids of this size are likely fragments from ancient collisions in the main belt, broken pieces of bodies that never became planets. Their surfaces are records of cosmic violence, scarred and reshaped by impacts across billions of years. Some carry carbon compounds, others metals, some even water-locked in minerals. If QV5 were sampled, perhaps by a mission akin to Hayabusa or Asteroid, it could reveal chemistry frozen since the dawn of the solar system. Each pebble carries a memory of creation, and in these fragments humanity finds not just threats, but archives of deep time. There is also the speculation of risk. An object 11 meters across cannot extinguish civilizations, but it could devastate a city. Imagine a trajectory shifted slightly earthward. Its atmospheric entry would produce an explosion in the lower stratosphere. A fireball as bright as the sun. The resulting shockwave would flatten buildings, shatter windows, ignite fires. Chelyabinsk was a warning, Tunguska, a prophecy. If such an object were to strike directly above an urban center, casualties could number in the tens of thousands. Such speculation is not sensational, but statistical. Models suggest that city-killer asteroids strike Earth on timescales of centuries. The date is unknown, but inevitability is written in probability. From risk flows a broader speculation, the role of impacts in shaping life itself. It was likely asteroids that delivered water to a young Earth, bearing icy cargo from the outer solar system. It was asteroids that may have carried organic molecules, laying groundwork for biology. Yet it was also asteroids that reshaped evolution through catastrophe. The extinction of the dinosaurs 66 million years ago is etched in the boundary layer of the Earth, a line of iridium marking a single impact that reset the course of life. Smaller events may have culled species, redirected ecosystems, changed climates. Each asteroid that brushes past reminds us that the hand that gives life can also take it away. Another thread of speculation is technological. Humanity has begun to see asteroids not only as threats, but as resources. The metals within them, the nickel, iron, platinum group elements, could one day fuel industries beyond Earth. A rock the size of QV5 may be small, but in larger cousins lie fortunes beyond measure. Some envision fleets of robotic miners, redirecting asteroids into stable orbits, harvesting them for construction. Yet such visions sit uncomfortably beside the risk of uncontrolled encounters. What can be moved may also be misused. The thin line between opportunity and danger defines humanity's relationship with these cosmic bodies. Speculation also touches philosophy. If civilizations elsewhere exist, do they face the same peril? Do alien astronomers watch their skies with equal vigilance, charting their own versions of QV5, wondering when fate will align stone and world? Perhaps asteroid defense is not only a challenge for humanity, but a universal threshold for any species that rises to intelligence. To endure, one must learn to see, to calculate, to prepare. Failure is not always sudden. Sometimes it is written in stone, orbiting silently until the moment of impact. Theories continue at the level of celestial mechanics. Some argue that small asteroids may fall into resonant patterns, repeatedly approaching Earth in rhythms that defy simple prediction. Others suggest that thermal forces, like the Yarkovsky effect, can slowly reshape their paths, altering futures in ways beyond present calculation. Over centuries, a body like QV5 may drift into new courses, creating futures invisible today. Theories remain cautious, but each adds layers to the uncertainty, reminding us that knowledge is provisional and vigilance eternal. Speculation extends even further into thought experiments. What if QV5 had been undetected and had entered unnoticed? Would humanity have been prepared? Warning times of days or hours offer little chance for defense. In such a scenario, the only response is resilience, the capacity to endure and recover. Some theorists argue that the greatest danger is not the rock itself, but human unpreparedness. Cities unfortified, governments uncoordinated, societies unaware. The cosmic threat thus becomes a mirror of human fragility, reflecting less the strength of stone, more the weaknesses of civilization. Yet speculation is not only warning, it is also inspiration. Each asteroid carries mystery, and with mystery, possibility. Perhaps the next visitor will be sampled by spacecraft, its dust returned to Earth. Perhaps future telescopes will detect hundreds of similar bodies, cataloging them until the unseen becomes the known. Perhaps the act of watching the skies, of calculating trajectories, of preparing for impact, will become one of the defining achievements of humanity, uniting nations in the face of a cosmic challenge. For in the end, asteroids are not enemies. They are natural parts of the solar system, reminders that Earth is not isolated, but part of a larger, evolving story. And so, the passage of 2025 QV5 invites speculation across scales. From chemistry to civilization, from impact to opportunity, from the local to the universal. It was a harmless rock, passing at a safe distance, yet it stirred questions that reach into the deepest corners of science and philosophy. It showed that even the smallest visitors carry significance, not because they struck, but because they might have, and because they always could. Each near miss is both a warning and a gift, sharpening vigilance, fueling imagination, and reminding humanity of its place beneath the stars. The near miss of asteroid 2025 KV5 did not end with its passage. For astronomers and planetary defense specialists, each encounter becomes an opportunity to test the growing arsenal of tools designed to guard Earth against future impacts. In the silence of the void, instruments watch, simulate, and prepare, weaving a net of vigilance that is still fragile, but stronger than ever before. The most dramatic demonstration of this vigilance came in 2022, when NASA's Double Asteroid Redirection Test, known as DART, deliberately struck the small moonlet Dimorphos. The collision altered its orbital period by more than half an hour, proving that humanity can nudge a celestial body, however slightly, from its course. In March 2025, final mission reports confirmed that the deflection was both measurable and sustainable. This marked the first true test of planetary defense, no longer theory, but practice. The asteroid QV5 itself posed no danger, but its discovery renewed attention to such missions. Reminders that prevention is not science fiction but tangible engineering. The European Space Agency's Hera spacecraft, launched in 2024 and now operating near Dimorphos, has deepened that proof. By July 2025, Hera had returned close-range images of the crater carved by DART, the boulder fields around it, and the dust ejected into space. Momentum transfer data, carefully analyzed, revealed how kinetic impacts scale with asteroid composition and structure. For scientists, this information is essential, for no two asteroids are alike. Some are monolithic rock, others loose rubble piles held together by weak gravity. The success of deflection depends on knowing the difference, but defense begins long before impact. It begins with discovery. The detection of QV59, days before its flyby, illustrated both progress and limitation. Ground-based networks like Atlas in Hawaii and Chile, and Pan-STARRS atop Helioclub, scan the heavens nightly. Their cameras sweep vast fields, catching faint points of light that move against the fixed stars. Algorithms sift those points, searching for motion consistent with a near-Earth trajectory. For small objects, warning is often measured in days. For larger ones, weeks or months. Yet even this is a triumph compared to a century ago, when asteroids were tracked by painstaking comparison of photographic plates. New instruments promise to transform this vigilance. The Vera C. Rubin Observatory in Chile, slated to begin full operations in 2026, will survey the entire visible sky every few nights. Its immense mirror and wide-field camera will catch countless faint bodies, cataloging them with unprecedented speed. Where today hundreds of near-Earth objects are found each year, Rubin will increase that number to thousands. The unknown will shrink, the blind spots narrow. Equally transformative will be space-based observatories. The NEO Surveyor, a NASA mission now under development, will carry an infrared telescope beyond Earth's atmosphere. From orbit, it will see the warmth of asteroids invisible in optical light, particularly those hidden in the glare of the sun. These are the most dangerous, the so-called daylight objects, which approach unseen from the solarward side. NEO Surveyor will expand humanity's reach into this hidden zone, revealing rocks that ground-based telescopes cannot touch. Radar, too, remains a cornerstone. Facilities like the Goldstone Deep Space Communications Complex send beams of radio waves toward passing asteroids, then record the echoes. From these echoes, astronomers extract shape, spin, and surface features. For QV5, radar sharpened orbital predictions, reducing uncertainties to narrow margins. In the future, more powerful planetary radar systems are envisioned, capable of imaging even small objects at great distances, providing data essential for any deflection mission. International coordination has grown alongside these tools. NASA's Planetary Defense Coordination Office, working with ESA and other agencies, maintains watch lists of potentially hazardous objects, updating orbits continuously. Simulations of impact scenarios are conducted regularly, not as exercises in fear but as rehearsals. They test communication, decision-making, and response at global scales. In these rehearsals, scientists imagine an object larger than QV5, but smaller than Apophis, weeks from impact. They ask what resources could be mobilized, what messages delivered, what actions taken. Each test strengthens the resilience of the system. Still, limits remain. Small asteroids evade detection until late. Warning times are short. Deflection requires years of preparation, not weeks. For objects like QV5, humanity could do little beyond evacuation if a collision were imminent. Tools like DART prove the principle, but their application requires foresight, the luxury of decades. In this lies the paradox of planetary defense. The greatest dangers are those not yet seen, and the most effective solutions demand time. Yet the work continues, driven by both caution and curiosity. Each instrument deployed, each asteroid tracked, adds to the map of our cosmic neighborhood. Each mission tested builds confidence that the trajectory of fate can be altered. The scientific tools of planetary defense are not shields in the traditional sense. They are lenses, algorithms, simulations, and spacecraft. Together they weave a safety net that grows denser each year, though never complete. As QV5 drifts away into the dark, its passage leaves no scars on Earth, only data. But in that data lies proof of vigilance, and in vigilance lies preparation. Humanity cannot silence the cosmos, but it can watch, learn, and act. The asteroid's approach was safe, yet it became another rehearsal, another chance to measure not only stone against sky, but science against time. In the quiet aftermath, the tools of defense remain turned outward, their purpose not to end the mystery, but to ensure that when mystery deepens into danger, the response is ready. The story of Asteroid 2025 QV5 ends not with impact, but with absence. The stone has passed, Earth unmarked, the skies unchanged. Yet its brief crossing leaves an imprint deeper than any crater could carve. It leaves the memory of a world nearly unaware, and the realization that vigilance is both fragile and essential. For scientists, the numbers now rest secure, an orbit defined, a century before its return. For humanity, the meaning runs further, into philosophy and reflection, into questions of place and survival beneath the stars. To reflect on this passing is to confront fragility. The Earth spins within a field of debris, relics of creation that circle endlessly, crossing orbits with indifference. Civilizations rise, cities grow. Cultures flourish all under a sky where chance encounters with stone can alter the course of history. The Tunguska explosion of 1908, flattening thousands of square kilometers of forest, happened in a wilderness. Had it struck a city, history books would remember it not as a curiosity, but as catastrophe. The Chelyabinsk event of 2013, though smaller, injured more than 1,000 people, reminding the world of vulnerability. Against this backdrop, the silent pass of QV5 becomes a meditation on fortune. It is luck, not certainty, that has spared Earth again. This recognition carries emotional weight. Humanity tends to believe in permanence, the permanence of its cities, its nations, its institutions. Yet the cosmos shows otherwise. Permanence is illusion. Even mountains erode, even oceans recede, even civilizations collapse. And above it all, asteroids drift, reminders of impermanence far greater than human memory. QV5's trajectory, calculated with precision, assures safety for now. But its very existence, discovered only days before arrival, shows how precarious knowledge remains. Philosophers and scientists alike have long warned of such fragility. Stephen Hawking, in his final years, listed asteroid impact among the existential risks that could end human history. Alongside nuclear war, climate change, and artificial intelligence, his words were not prophecy, but perspective. The risk may be small in any given year, yet over centuries, it becomes certainty. Carl Sagan, decades earlier, framed the Earth as a pale blue dot, fragile against the cosmic dark. For Sagan, the lesson was humility. For Hawking, it was urgency. Together, they form the philosophical twin pillars of planetary defense: to see clearly and to prepare faithfully. The emotional reflection deepens when one considers the silence of the cosmos itself. An asteroid does not choose its path. It does not seek to harm or to spare. It follows the laws of motion, set in place long before human beings walked the earth. In that silence lies both terror and beauty. Terror, because fate can arrive unbidden, indifferent to human endeavors. Beauty, because within that indifference lies the grandeur of natural law, a cosmos unfolding in perfect consistency. From the fall of an apple to the arc of a bus-sized rock past the earth. For those who watch the skies, QV5 is not only a calculation, but a reminder of responsibility. To detect, to catalog, to predict, these are acts of stewardship. Humanity may not control the cosmos, but it can control its awareness. The act of watching itself becomes a form of defense, a discipline that bridges science and philosophy. To measure a stone drifting at 500,000 miles is to affirm that humanity is not blind. To predict its return in a century is to affirm that vigilance transcends generations. In that way, QV5 becomes a symbol not of fear, but of continuity, of the ongoing effort to safeguard the future. Yet reflection also touches on humility. The same science that predicts trajectories cannot guarantee permanence. Small forces, like the Yarkovsky effect, can shift paths subtly across decades. A prediction today may not hold in a century. Humanity must accept this uncertainty, not as failure, but as reality. The humility lies in admitting that even with instruments spanning continents and spacecraft probing asteroids directly, not every stone will be found, not every future foreseen. The cosmos remains larger than the net we cast. This humility extends into culture. Near misses like QV5 capture public attention for days, then fade. Headlines vanish, interest shifts, vigilance wanes. Yet the stones continue their orbits regardless. Philosophers of risk argue that humanity's greatest weakness is not the rocks themselves, but the forgetting. Each generation must be reminded anew, must inherit the duty of vigilance. The passing of QV5, then, is not an end, but a passing of responsibility from astronomers of today to those who will watch the skies when it returns in 2125. There is also inspiration in this reflection. To face vulnerability is to recognize potential. If humanity can track stones across the heavens, can calculate centuries into the future, then it has already achieved something extraordinary. No other known species has looked upward and foreseen its own possible end. That foresight itself is power. It means that threats need not be fate. With preparation, with cooperation, with technology, impacts can be deflected, futures altered. In this, the fragility of Earth is balanced by the resilience of its people. Consider the image of Earth from space, a sphere of blue and green, fragile against the black. Around it drift countless unseen wanderers. Yet around it also circle spacecraft, radar beams, telescopes, scanning night after night. The story of QV5 is not only about what almost happened, it is also about what humanity has chosen to do, to watch, to learn, to prepare. Each discovery adds another layer of protection, not physical, but intellectual, a shield built of knowledge and foresight. In the end, the asteroid's near pass becomes a parable. It speaks of fragility and vigilance, of chance and choice. It reminds us that life on Earth exists in a balance both precarious and profound. The cosmos will continue, with or without us. Stones will wander, stars will burn, galaxies will drift. But within that vastness lies the possibility of endurance, if vigilance is kept. To watch the skies is not only science, it is philosophy, an act of acknowledging both the danger and the wonder of existence. As QV5 fades into the outer dark, unseen until its return a century hence, its legacy is not numbers or orbits alone. Its legacy is reflection. Reflection on the silence of the universe, on the fragility of life, on the responsibility that comes with awareness. For a fleeting moment, a bus-sized traveler brushed past Earth, and in its passing, it reminded humanity of its place, not secure, not eternal, but aware. And in that awareness lies both humility and hope.